So far, we've been using the algebraic formulas for compound interest to actually calculate things like future value, present value, and effective rate. But there is a way to do these same calculations or get these same answers with spreadsheets, whether that's Google Sheets or Microsoft Excel or even the number spreadsheet that you use maybe in a Mac computer. Let's look at each of these formulas in turn and what the spreadsheet entry would look like. Okay, so when you're working with a spreadsheet and you want to do a calculation, you always want to start with an equals, and then we're going to start with the title of what we're trying to find. If you're trying to find a future value, which is also equivalent to A in our algebraic formula, you would start with FV for future value. Then we're going to enter the rate involved in the problem. Now, that's specifically the rate per compounding. Okay, so that would be not the annual interest rate, but it would have to be the interest rate divided by how many compoundings there are per year. So one example where we found the future value was this one with Yori. Yori invests $9,000 in an account earning 6% interest compounded monthly. So if I were to enter the rate into a spreadsheet formula, I'd have to enter 6% divided by 12 for R. Okay, so I have to incorporate that I'm dividing by 12 because I'm earning interest monthly. And so I have to divide the annual rate by 12 months. The next entry in a spreadsheet would be the number of periods. And that's actually, again, not the number of compounding periods per year, it's actually the total number of times I earn interest. So this has to be the number of times I'm earning money each year, which would be monthly, times the number of years that we go out. So 12. So this rate is really R divided by N, and the number of periods is really N times T. So it's important that you recognize that. The next entry you would have to tell a spreadsheet is something that's called a payment amount. And the payment amount would be if we have, refers to if we have regular payments. In this case, we don't. We're investing once and then we leave it alone. So there is zero payment amount in this example, so we would just enter 0 in. The present value refers to the amount you start with. That would be principal, P. One hint, though, is you cannot use a comma if you enter in a big number. So here we would enter in 9,000 because you were invested 9,000, but we would not put a comma after the 9. And then the last thing, that's given here is something called end or beginning. And this is really a technicality. It has to do with whether you are earning the interest at the beginning of the time period or at the end of the time period. In all of the examples, we're going to use this term. We're always going to earn interest at the end of the time period, which is what all spreadsheets assume. And so since we're going to be doing the general way of doing this, which is earning interest at the end, we don't have to enter anything for that. But I threw it in just because if you see it being told to you in the spreadsheet, I wanted you to know that it's what we're going to do is use the assumed value that the spreadsheet uses, and so we don't have to enter that in. So we'll look at that in a minute in the actual spreadsheet in Google Sheets, but I want to just point out that the present value formula is almost identical, except for present value, we are going to have PV for present value, and remember with present value, we're finding P in the formula. The rate is still going to be R divided by N. So in this example that we did where we were trying to get to $80,000, a future value of $80,000 after 18 years, if you have an initial amount invested at 6.8% compounded quarterly, we would be using a rate of 0.068 divided by 4 for quarterly. Number of periods is going to be the total number of times we earn interest, which would be N times T. So in this example that we did earlier, that would be N, which is quarterly, so 4 times 18 years. And then payment amount is, again, if you're giving money on a regular basis, we are not, so that would be 0. And then we would want to know our future value is how much we want to have at the end. So that would be 80,000. But you have to be careful not to put the 80,000 in with a comma. So this would be the future value, or A. Effective rate only relies on two things. It relies on the annual interest rate R and the number of compounding periods per year, which is just n. So you only have to enter in two things, but the abbreviation for effective rate is effect in all of these spreadsheets. So again, we always start with an equals and then the name of what we're trying to find, future value, present value, or effective rate, effect in this case. And then we enter in these entries that are based on what the problem is about. So let me take a look at this next within Google Sheets, which is one spreadsheet you could do this within. But you can do this with Excel or with really any spreadsheet that you happen to have on your computer. I'll briefly demo these three formulas in Google Sheets. So I've opened up a Google Sheets spreadsheet, and I'm going to go ahead and type in the future value formula for that example with Yori. Now in Google Sheets, to get it to calculate anything, you want to click on one of the cells, and I've expanded the cell here just to make it easier to see everything. And I'm going to start with an equals. Anytime you calculate something, start with an equals. And then if I want to find a future value, I'm going to type in FV for future value, and it reminds you that's what you're looking for. It actually has a formula for that. And then the parenthesis, and within the parenthesis, I'm going to put the values involved in the problem. Google Sheets will actually give you hints here. It's saying rate is the first thing you plug in. Now the rate for the problem with Yori is a 6% annual rate, which would be 0.06. And then, but this investment was compounded monthly. So we need to divide by 12 because Yori doesn't earn that full 6% every quarter, or sorry, every month. They earn a 1/12 of that. Then we're going to put in the number of periods. Well, Yori is earning interest 12 times a year for 25 years. So we put 12 times 25 in, comma. Then the payment amount. The payment amount would be if we were making regular payments every year. We're not, or every month. So we're going to put 0 in. What we have done is we've started with a certain amount of money. We've started with $9,000, and that's what we definitely want to enter in. The next thing is that end or beginning, and because we are going to use what is basic for all spreadsheets, we're going to ignore that and not put it in. We're just going to close our parentheses and hit equals. So what we get here is an answer that says negative $40,184.73. That is exactly, if you ignore the negative, what we got when we did this problem earlier. Yori would have $40,184.73 in the account after 25 years. Google Sheets puts a negative here, and if you're using Excel, you'll see this in red. That also means negative. What that negative is representing is that you really don't have that money yet. It's money that would be in the future. Okay. If you want to see your formula again, you can just double click on that cell and it'll bring up exactly what you entered in. If I hit enter, it'll go back to the actual calculation. Let's look at the present value formula for that second example involving saving up $80,000 for your daughter's college fund. So I would start with an equals and then put PV for present value, parenthesis, and then enter the rate in. In that example, the interest rate for the year was 0.068, but we were earning interest quarterly, so we need to divide by 4. Then how many times did we earn interest? We earned it 4 times a year for 18 years, so 4 times 18, comma. There is no regular payment, so I'll put a 0 in there, but we do know that in the future we want to have $80,000. Be very careful not to put a comma in that $80,000 because the spreadsheet will interpret the comma to not mean what you mean it to be. Close the parenthesis, hit enter, and there's that $23,767.38 that we worked out earlier should be what you start with to get $80,000 after 18 years. So once again, if you want to look at the formula again, we double click on the cell. There's what I've entered in, and then hit enter, and there's the value. The last thing is effective rate. To find the effective rate, we hit equals, we type in effect for effective rate, and then we only need to enter 2 things to calculate an effective rate. It's all based on the annual percentage rate and the compounding periods per year. So in the example I have with account A, 0.086, 0.75 is the annual interest rate. And then the periods per year, there were 52 because there's 52 weeks. Close the parenthesis, hit enter. Here is our percentage rate, 9.14 if we rounded. This takes it out quite a ways, but one thing to note is that the spreadsheet will not change it into a percentage. You need to be able to move the decimal point to make that into a percentage rate. All right, so that's using spreadsheets. It's really your choice whether you want to use the spreadsheet as you're doing homework problems for this section in My Open Math, or use the algebraic formula. However, as we move on to later topics in this chapter, using the spreadsheet will be really helpful because the algebraic formulas become much more complicated. So that we're going to use these spreadsheet formulas quite a bit in future sections.